Okay, so this is the first video for chapter 5, which is about thermochemistry. It's a fairly short chapter, which is okay. It's dealing with how much energy is gained or lost during reactions, or how materials absorb or release energy. So we need to talk about energy, kind of define a few things here. Okay, so there are two types of energy. Any of you have had physics, have probably seen all this before. We're just going to kind of briefly talk about some of this. The most obvious answer is kinetic energy. And this is the energy of a moving object. Okay, there's an equation for this. We're not going to do anything with it, but we're basically going to derive some units and talk about how this works. But the kinetic energy is equal to 1/2 the mass times the velocity squared. Mass, velocity. Velocity is speed. Okay. So in terms of units here, SI units, the physics units here, mass is kilograms and velocity is meters per second. So the overall units here would be kilogram meters squared per second squared, because velocity is squared. This is the unit of a joule. Okay, generally abbreviated as just a capital J. This is the unit of energy that we are going to use for pretty much everything. Okay, there are other units like calories. There's nothing wrong with the unit of calories, but chemistry we tend to use joules as the default answer. So in terms of visualizing kinetic energy, it's based on how heavy something is and how much speed it has. So this is why if you get hit by a train, which has a huge mass, and it's only going like 10 miles an hour, it could kill you because it has so much mass that the overall energy being transferred is enough to kill you. But by that exact same logic, if you have something like a bullet, which is really, really, really lightweight, that has really, really high speed, it could also kill you. I'm not saying they have the same energy, but the idea is that both parts are important. When we talk about chemistry, this is the energy of chemical reactions. Basically, we're talking about bonds breaking and bonds forming. Whenever bonds are formed, energy is released. Whenever bonds break, energy is absorbed. You have to put energy in to make that happen. Okay. So, not a huge deal. This is pretty obvious stuff. This is what we typically think of when we think of something having energy. We think about it moving. Same thing here. The chemical reactions, the atoms are literally moving. They're breaking apart and rearranging and doing new things. Okay. There is also something called potential energy. And this is essentially stored energy. So, for example, if you have, let's just see if I can do one. All right. So, if you have a pen and gravity pulls on it, what's going to happen is the motion, the mass of this and the force of gravity is going to apply to this and is going to pull it down, and it falls. It has kinetic energy because it's falling. Okay, kinetic energy. Potential energy is more like this. This could fall, but it hasn't yet. So we're kind of waiting for it to release its energy. It's stored, it could release this energy, but it's not yet. In order to get potential energy converted to kinetic energy, you have to apply a little bit of energy in there. Okay, so it finally fell, converted to kinetic energy, the energy was released. Let's see if I can put this back somewhere useful. Okay. So it's essentially stored energy. And it requires heat or light or, I don't know, motion, I guess. to release it. Okay. When we talk about chemistry, what we're talking about is chemical stability. In general, unstable molecules require very little heat or light or motion to release this energy and convert it to kinetic energy. Basically, unstable molecules are easily converted to kinetic energy. Stable molecules tend to just sit there and just be happy. Okay? They are unreactive. Let's go with that. Okay. So, for example, gasoline is an unstable molecule. If you have gasoline sitting in a container, it has a lot of potential energy because it is an unstable molecule. Now, this doesn't mean that if you have a can of gasoline that is going to explode, it's going to release all that energy. You have to put a source of heat into it. So if you flicked a match at a can of gasoline, it is not a lot of energy to throw in there, but it's enough to easily convert it back to kinetic energy. Basically, all the particles start moving around, the bonds start breaking and forming, and yeah. Whereas if you had something like water, water is a very stable molecule. If you throw a match at water, it puts the match out. Okay, because water has a relatively low potential energy. Okay. So, not a huge deal, but a little background on energy. Yeah, so let's stop there.